Today we're looking at dilations. We're going to verify and use properties of dilation. A dilation is a non-rigid geometric transformation. A dilation maintains the shape, it's the same shape of the object while changing its size. So maybe it's getting bigger or maybe it's getting smaller. A dilation changes a figure in such a way that each of the angles are unchanged, and each of the line segments of the dilated figure is longer or shorter than the original segment by a scale factor of the dilation. The scale factor is the ratio of the length of the image to the corresponding length of the pre-image, with the image length always in the numerator. If the scale factor is greater than 1, the dilation is an enlargement. If the scale factor is less than 1, the dilation is a reduction. A line segment passing through the center of dilation remains the same line in dilation, and a line segment not passing through the center of dilation is moved to a parallel line to the original. So what does that mean? Let's just say I draw a triangle here, and if I'm going to copy and paste this, this is a congruent triangle. It hasn't been changed at all, but I can move it around and put it right on top and it would be exactly the same. Now if I resize this would have a dilation. I can line it up where all of the angles are exactly the same, but the sides have been increased by a scale factor. So I can take this and I could measure the sides and it would make a proportion. Now since it got bigger, the scale factor is going to be a number greater than 1. So this would be an enlargement. But I could have also made this smaller and the angles still line up, but the dilation would be smaller than 1 because it's a reduction. So it would be like a fraction, like maybe 1/2 or 1/3 or 4/5, something like that. Examples 1 and 2, we're going to just skip for now. It's an in-class activity, so if you were not in class, we're just going to skip over that and go to the next section.
Looking at example 3, we have this point C. Now, if I take this point C and I go all the way to the original P, that's that bottom square, altogether it's 4. So, but from the small section, the small square to the C is only 2. That number goes on top. I take my P prime and the length between C and P prime and divide it by the length from C to the big P. So P prime divided by P is going to equal our K, which is our scale factor. 2/4 equals 1/2. This is a reduction because it's less than 1. Now on this next one, my P prime from C to P prime is 25. The length from P to C is 20. If I reduce that, 5 goes into 25 5 times, 5 goes into 24 times. 5/4 is the same as 1.25. This is bigger than 1, so it is an enlargement. We're starting with P and we're ending with P prime. So we always start with P and then P prime is our second. On this next example, we have the original it says the large triangle is the image of the small triangle after a dilation. So the red image is our P prime. So we have 15 is our P prime over 9, okay? So we take our P prime divided by P, and that will give us, we're going to reduce that. Okay, so 3 will go into 15 5 times. 3 goes into 9 3 times. So this is equal to 5/3. Now 5/3 is going to, we're not trying to find what the scale factor is, we want to find what x is. So I want to take 5/3, and that scale factor is going to be the same as 35 divided by x, we're going to set those equal to each other because the scale factor on those will be the same. So we are going to find our cross products. I'm going to take 35 times 3, and that is going to be equal to 5 times x. 35 times 3 is 105. I'm going to divide both sides by 5. And 5 goes into 105 21 times. So x would be 21. 35 over 21 is going to equal 5 over 3. Now looking at example 6, we have 3 points. We have the point -3, 1, -4, -1, and -2, -1. So we're going to just go ahead and plot these 3 points. We have A, B, and then C was the -2, -1. Our scale factor is going to be 2. So we are going to take all of these points and we are going to multiply them by 2. So on A, I take -3 and times it by 2 to get -6, and 1 times it by 2 to get 2. B, -4 times 2 is -8, and -1 times 2 is -2. On C prime, we take -2 times 2 is -4, and -1 times 2 is -2. All right. So let's go ahead and plot those points. We have -6, +2. Then we have B is -8, -2. We have to go a little bit off the graph here to plot that, and C is -4, -2. Now this is A prime, B prime, and C prime. This is the after image. That's why we have the prime on them. On number 7, we have the point -6, 0. We have -3, 0. 0, 6 over 0 up 6, and -3, +6. This is a parallelogram. Let's go ahead and label the points S and R up top and P and Q on the bottom. Connect all the sides. Nice parallelogram there. So our K, our scale factor, is 1/3. All of these points are going to be 1/3 of the sides. So we take -6 and times it by 1/3. 1/3 of 6 is -2. 1/3 of 0 is 0. 1/3 of -3 is -1. 1/3 of 0 is 0. On R, we have 1/3 of 0 is 0. 1/3 of 6 is 2. And on S, we have 1/3 of -3 is -1. 1/3 of 6 is 2. Go ahead and plot those P, Q, R, and S primes. We have -2, 0, -1, 0. Then we have 0, 2, and -1, 2. That's all of the angles are the same, but the sides have just gotten smaller. Let's label these. S prime and R prime up top, Q prime and P prime are on the bottom. Now here is like a real world example. You design a poster on an 8.5 by 11 inch paper for a contest at your school. The poster of the winner will be printed out on a 34 by 44 inch canvas to be displayed. So we want to figure out the scale factor. We start with our original image, the 8.5 by 11. If I take 11 and times by 4, I get 44. 8.5 times 4 is 34. So our scale factor is 4. This is an enlargement of that image.